This will be a short video, just kind of continuing with the notes from yesterday, but I did want to make sure that you at least could see an example when we graph a linear equation. I know that you guys did a graphing project last year, so I feel like you probably got a lot of practice with graphing, but I still think it's good to have at least one example to look at before you get going on your own on the worksheet. So in this problem, we're continuing with problem 5 in the notes. I just call this day 2. We're going to be graphing linear equations, so using slope-intercept form. So in this problem, it's good to identify your slope and your y-intercept. When you graph your y-intercept, we think of that kind of like our starting point. So when you graph, for example, I can see we're starting at 4. So on my graph here, I would go up to 4 and make a dot. And then I would also need to look at my slope. Excuse me. This slope tells me my rise over my run. So that negative could carry to the top or the bottom of your fraction, but we know that it needs to be -3 over 1 as far as telling us what to do from our starting point. So I'm going to use the negative with the numerator. So that means I would go down 3 and then right 1. When it's positive, you go to the right. So just to kind of review those rules real quick, if you're going up or if you're going to the right, those directions represent positive values. If you have to go down or left, those are going to represent your negative values. So in this case, I started at 4, which is my y-intercept. So then I went down 3 and I went right 1. So I could continue to do that. I really like you guys to have 3 points to graph. So if we could just do it one more time, 1, 2, 3, and right 1. That gives us a strong kind of relationship there. I could also go up 3 units and then left 1, but you can see that I'm now going off the grid. So I would prefer that you, when you're doing your rise over your run, that you keep on the graph paper that is given. That just makes it a little easier too when we're graphing. So then I would connect those together and there is my line. So I have graphed the equation y equals -3x plus 4. Again, I know that you've probably had some practice with that from last year, but it has been a while, so I think it's good to go over some of those few reminders, okay? We also have another problem here, modeling a function rule. So in this problem, we are going to look at a word problem and graph that relationship. Sorry, I'm turning to the right page in my notes to make sure that I get the numbers correct because I already have those calculated. Okay, so here we have a plumber that charges 65 fee for a repair plus 35 per hour. So probably I want to start by writing my equation. So I'm going to have y, we want it to be in the form y equals mx plus b. So y is going, I'm sorry, I keep meaning to say m. M is going to be your 35 per hour. That is, and then what did we start with? We started with a $65 fee. So that is going to represent our y-intercept. So here is our equation that we can use to help fill in a table of values. And then once we have a table of values, we can graph those points. So in this case, using this equation, I would take 1, plug it in for x, so that we would end up with 100 here. And then I'm going to just continue with my hours and continue to plug those in for x into my equation and solve for y. So I ended up with 135 here, 170, and 205. Now I can take those values and just plot those. I can see here that this is going to represent my hours, the x-axis, and on the side represents your total cost. So I think it's always a good idea to label those when you're graphing. So we start with 0.65, and I would say you just want to kind of estimate where that would go since we can't see the exact value there on the graph. Then I would go 1 to 100, then 2 to 135. Again, just kind of estimating where that would be. 3, 170. So I know that's right, maybe just right there. And then 4, 205. Again, just estimating where those would be, and then we could connect these together to show that relationship. So this graph would model that relationship for hours and total cost for the repairs. So being able to graph using slope and y-intercept, and also being able to interpret a problem and be able to represent that problem in a table and a graph and equation. So here we're kind of using all the forms for problem 6. I just want to do a quick check here for understanding. This is something we hadn't really talked about. For this quick lesson check here, it says, is y equals 5 a linear equation? So first I want you to think about, does y equals 5 have a slope? How do you know if it has a slope or if it doesn't? Well, think about, does it have the variable x, and does it have a coefficient in front of x? Because that is the number that represents slope. So in this case, does y equal 5 have a slope? The answer would be no. In this case, it represents a horizontal line. Now they asked to find 3 points that satisfy this equation. So before I do that, I should kind of clarify that. I should say it doesn't have x variable with a coefficient, but when we talk about horizontal lines, we do say they have a slope of 0. So even though I said it doesn't have a slope, technically it does have a slope of 0. So I should clarify that a little bit. Find 3 points that satisfy this line. So it has to all line on a horizontal line with 5. So we could use 0, 5. We could use 1, 5. We could use 2, 5, and just continue that pattern. As long as the y value stays the same, it's going to make that horizontal line. So is y equal 5 a linear equation? And the answer is yes. It is a straight horizontal line through 5. And as I said, it doesn't have, in 27, it doesn't have necessarily like a coefficient with x, but it does have a slope of 0. So I probably should have just said, just cross that out and say it does represent a horizontal line and they always have a slope of 0. Maybe that would be a little bit better. I didn't really like how I worded that after I looked at it. Okay, so today's assignment is going to be working on the worksheet. So you will get practice with graphing using your slope and your y-intercept. Just make sure that your equation is in slope-intercept form. So make sure that you have solved for y if needed. There's a few equations where you need to have y by itself. So make sure that you get y by itself before you start graphing. That's just kind of another reminder there when you're graphing. Okay? That is the end of my video, so I'll pause and you can start on the worksheet.